Page 39, Note 7E, Solving Radical Inequalities. Example 1, Radical Inequalities. Solve. A. 3 times the square root of x minus 1 is less than or equal to 12. The first thing we would do is isolate the square root. Divide by 3 each side. So we have the square root of x minus 1 is less than or equal to 4. From here we're going to exponentiate each side by 2. So then we have x minus 1 is less than or equal to 16. Add 1 to each side, and then we have x is less than or equal to 17. So that's your solution. X is less than or equal to 17. And if you were to graph this on the number line, you'd have a point with a 17, and then x is less than that, so we'd shade the left side. B. 7 times the square root of x plus 1 is less than or equal to 15. To isolate that square root, first subtract 1 from each side. 7 square root x is less than or equal to 14. Divide each side by 7. The square root of x is less than or equal to 2. Exponentiate each side by 2, and then you get x is less than or equal to 4. So that's our solution. And to graph this on the number line, we plot 4, and then we shade to the left. C. 2 square root x minus 3 is greater than or equal to 3. Let's add 3 to each side to start isolating that square root. To further isolate that square root, we can divide each side by 2, and then you have the square root of x is greater than or equal to 3. Exponentiate each side by 2, and then we have x is greater than or equal to 9. So one more thing with A and B. There's also a low point because you can't have a negative beside the square root, or it would be considered imaginary. For this one, x can't be any smaller than 0. So our endpoint is going to be 0. For A, for this one to be true, x can't be any smaller than 1. We basically set the inside equal to 0. Or actually, we'll set it greater than or equal to 0. It doesn't affect C since there's no numbers less than 0 that is greater than 9. Example 2. Use the graph of the inequality shown below to determine if the following points are solutions or not. Circle yes if the point is a solution and no if not. 1, 0. So what you want to do is plot the point and see where it is. So 1, 0 would be right here. That is not in the shaded spot, so we'll put no. 6, 1. That's like right here. That is a yes. That is in the shaded region. And then we have 13, 2. That's also a yes. Now let's just say that we had let's do a D, and then say that we had 5, 0. This one would be a no, since it's on a dashed line. If it's on a solid line, it would be a yes. If it's on a dashed line, it would be a no. Alright, let's look at example 3. Use the graph of the inequality shown below to determine if the following points are solutions or not. Circle yes if the point is a solution and no if not. So let's plot these points. Negative 1, 4. 1, 2, 3, 4. That's all a solid line, so it's yes. Negative 4, 3. 1, 2, 3, 4. 1, 2, 3. That would be a no. It's in a blank region, not a shaded region. And then we have negative 2, 7. And that's a yes.